Okay, review section 6. Going to go through some integral problems here. The first one is this combo function that we are going to try to graph and come up with some sort of a sense of what the integration might look like. So if we graph the original here, let's see here. Let's see if I can get a little more room. And we have the absolute value, x minus 2 is going to look over here. And then x plus 2, if x is less than 0, is going to look like that. And so this is your x plus 2. And then this actual absolute value x minus 2 is actually a combo function in and of itself. It is the function x minus 2 over here to the right. And then to the left is actually the reverse of that. If you take a negative sign, distribute it through there, it's going to be negative x plus 2 is your other part of the graph. So it looks like that. You're going to try to integrate that. If you kind of pay attention here from, we're trying to go from negative 4 to 6. And should be able to tell your answer is E. If you take a look at that graph, E is going to be the area under that curve. Number 4 is a good problem. You have the same function here, f of x, f of x, f of x. We're trying to graph. We don't know what it looks like, but whatever it is, we're looking for the area from negative 3 to 2. Or we're given that area, rather, is 6. So that's kind of going from left to right as a totaling device. That equals a positive 6. And then from, well, this is a little odd. It says from 2 to 1. So that's going the opposite direction, is 11. Okay, so this area is 11, but since it's going in the opposite direction, we're going to think about that as a negative 11. Okay, and so if you go from negative 3 to 1, this whole thing is going to equal a positive 6 minus a negative 11. Okay, because you subtract off that red area, and which is actually subtracting negative, so you're going to end up with the answer of positive 17. And the average value, that's the 1 over b minus a, 1 over 2 minus 0. The integral from 0 to 2, square root x dx is going to end up being c. Number 6 is a good problem to take a look at here. We have this k that's sitting in there actually in a couple different spots. K, remember, is just a number. It could be like 2 or 3 or e or pi. It's just a number. It's not so much a variable as x as compared to x. So we are just going to integrate this. Sorry about that. We're going to integrate this. And so we have the integral of 2kx. And so the power is going to go up 1 over the same number from 0 to k. And we know that equals 18 is what they tell us, okay, in the original problem here. Okay, so we have something like kx squared minus x cubed over 3 from 0 to k. And so you're going to put k in there first so that you kind of think about these big parentheses here. You're going to put k in there for the x. So get k cubed minus k cubed over 3. Now you put 0 in there for the x. You get 0 minus 0. And so you end up with k cubed minus k cubed over 3 equal to 18. And if you solve that, you should end up with an answer of 3. And the answer for 4 is D4. 26, I think we've seen that before, but that's from 0 to 1. It's actually going to be absolute value of x minus 1 dx. I have that as a 1/2 answer. And number 43 should end up with D. You can try that on your own. And this last page has got some good problems on it. This first one, we want to figure out an integral. So we see the integral. And let's go ahead and see if we can graph this right away here. So 8 minus x squared, upside down parabola from -2 to 2. And then you have right side up, just x squared parabola elsewhere. So you're looking from that, and we want the area under the curve from -1 to 3. Okay, so you can divide this up into two parts here. You're going to find you want to integrate from -1 to 2. The upside down parabola, 8 minus x squared dx, and then from 2 to 3, x squared dx. And you do get some fractions in there. Keep the fractions all the way through there. The answers here are a little bit odd in that you don't have to get the exact right answer, but it doesn't really save you any time because you have to use your fractions and keep those fractions all the way through, but you should end up with an answer of D. And number 13, you have a graph of cosine x. And went from -pi/2 to +pi/2. Separated in two regions. If the area of the region for this is going to be an equal sign there, 3 times the area of this region. Okay, and so it might take you a second, but you can kind of figure out K is going to be over on this side. Kind of want to draw it accurately here, and so the blue area is equal to 3 times the red area. And so when we write this, the blue area therefore is from -pi/2 up to K of cosine x dx, and that's going to equal 3 times the area from K to pi/2 of cosine x dx. Okay, so we just have to solve that. Okay, we integrate cosine, we're going to get sine. Let me keep working here. So on the left side here, we get sine of x, and you're going to go from -pi/2 to K. Let me see if I can do this in one step here. And so we're going to get sine of K minus sine of -pi/2 equal to 3 times sine of pi/2 minus sine of K. And get a little confusing there. Should end up with sine of K, looks like sync, but sine of K plus 1 equal 3 minus 3 sine of K. Okay, let me get some of this out of the way, and we're going to go back to that. And so we've got these sine of K's. Actually, I'm going to have 4 sine K equal to 2, so sine of K equals 1/2. Kind of on my way here. What value between -pi/2 and pi/2 is that it gives you what angle between those two gives you a sine value 1/2. Your answer there is pi/6. And so that turns out to be your answer. I did want to look at a couple of the other answers. Okay, so we have solved that. It's pi/6. Those first two answers, A and B, arc sine is a math term. If we had come out with sine of k equals 1/4, for instance, there is no easy angle that gives you a sine value of 1/4. Okay, so the actual answer there, a way of representing k, if you wanted to solve this for k equals the arc sine. That's the angle that gives you a sine value of 1/4. And so that's when you would have ended up with the answer for that they have for A. If it was sine of k equals 1/4, if you solve that for k, you would get k equals arc sine of 1/4. Okay, so we didn't end up there. We ended up with C, and so we're happy with that.